Hi, welcome to the class. Today we are going to do a last topic of Unit 2 and Chapter 1, that is current electricity. And the name of the topic is combination of cells. So before this we have already discussed combination of resistors and we discussed them in series and parallel. Today we will discuss combination of cells, and in the first case of this combination of cell I am going to take series. Okay. So I have here three cells connected in series. Cell 1, its internal resistance is given R. Cell 2, its internal resistance is given R. In cell 3, its internal resistance is given R. Right? Now pay attention that all these cells are connected in series, but this negative terminal of the first cell is connected to the positive terminal, and this negative terminal of this cell is connected to the positive terminal. Right? So they are connected in series. And this whole system is connected with an external resistance R with the help of a key K, and I current is flowing through this circuit, right? So what is the total EMF of this circuit? Total EMF of this circuit I am assuming that N cells are connected in parallel, in series, I'm sorry. N cells are connected in series, okay? So EMF will be added in this case. In what case? When they are connected in series. And how they are connected in series? When this negative is connected to the positive and negative is connected to the positive. Only then they will be added. So I am assuming that I have connected N cells. Okay, and the resistance of the EMF of all these cells is E and their internal resistance is R. Right? So total EMF will be N E and total resistance would be N R, because this is connected in series, and plus external resistance R. So what will be the current? Current will be EMF, that is Ne upon total resistance, that is NR plus R. So this will be the expression for current in this case, right? What if these cells are connected in parallel? I hope this part is clear now. What if these cells are connected in parallel? If they are connected in parallel, then their positive terminals will be connected to a point, and their negative terminals will be connected to a point. So this is the point where these positive of these cells is connected, and this is the point where negative of these cells is connected. Right? Again, external resistance R with the help of a key, K is connected. The current is coming like this. All the positives are connected at a point and all the negatives are connected at a point. EMF is E. Now remember one thing, whenever cells are connected in parallel, their total EMF will be equivalent to the EMF of a single cell. Their total EMF will be the equivalent to the EMF of a single cell. And what is the EMF of a single cell? In this case, EMF of the single cell is E. Right? So this EMF of all these cells would be EMF of all the cells. That is total EMF. Let me write it as total EMF. Total EMF would be E. What would be the total resistance? So the resistance of one cell is R. This is R. This is R. They are connected in parallel. So I will take the combination of these resistors connected in parallel, and the combination of these resistors taken in parallel will be 1 upon R. Or let me, because R is this, I will call it as R1. It will be 1 upon R plus 1 upon R plus 1 upon R. And how many cells are there? We have, so this will go up to N terms. Right? So it means N cells are there whose resistance is this much. So if one cell is having a resistance of 1 upon R and total number of cells is N, then total resistance will be, either you add up them or you just multiply this N by 1 by r. If you multiply this n by 1 by r, this will give you the same result. So this r1 would be r upon n. And then what would be the total resistance? Total resistance would be equal to r upon n plus this r. Now how much would be the current? So I will be equal to EMF upon total resistance, that is r upon n plus r. So this will be the expression for the current when the cells are connected in parallel, right? You can take the LCM also and then you can solve it. If I take the LCM, it would be NE upon R plus NR, right? Now let me solve some questions, that is numericals, based on these kind of problems. The first question on the numerical would be, so I'll draw the diagram and I'll ask you the question. I hope you understood that whenever the positive of all the cells is connected to a point and negative of all the cells is connected to a point, they are connected in parallel. And if the negative terminal of a cell is connected to the positive terminal of a cell, they are connected in series, right? And in series we can add up their EMFs, and in parallel we take the total EMF as to be the EMF of a single cell if the EMFs are equal. So this is the diagram. We have this negative, positive, then positive, negative, and this is the resistance. And then we have external resistance, right? So in this question I have this cell which is E1, R1, E2, R, and this is R. So let me write the values here. So if I write the value, E1 will be equal to 2 volt, E2 will be equal to 6 volt, R1 is 2 ohm, R2 is 4 ohm, and capital R is 10 ohm. They are asking you to calculate the total current. Now guys, in this case the negative of the cell is not connected to the positive, okay, but two positives are connected. So they are connected in series, but the arrangement is different. So how do we do this? So in order to calculate the net EMF here, what you will do, you will subtract the EMF of these two. Why subtract? Because positive is connected to the positive only. That's why. So it will be 6 minus 2. So net EMF would be 4 volt. It means in this case the EMF is flowing from this battery towards this battery after adjusting that negative EMF, right? What will be the total resistance? R net. That is total resistance. Of course they are connected in series. R1 2. So net resistance would be R1 plus R2 plus capital R. So R net would be equal to 2 plus 4 plus 10. 14, 16 ohm. This would be 16 ohm. Now you have to calculate. Now you have to calculate the current. So how do you calculate the current? So current will be I is equals to E net upon R net. E net is how much? 4. R net is how much? 16. 1 by 4. So I is equals to 0.25 ampere. So this is one type of numerical which you should understand. The only difference here was this positive and positives are connected. So you have to subtract them, right? Now one more I'll give it to you. This would be much easier. And we have to draw the diagram like that only. So instead of this R, it is 2.25 2.25 ohm. This is the other question. This is positive, this is negative. So here we have, this is a new question which I am doing, 1.5 volt and R1 is equals to 0.5. Here R2 is equals to 0.25 ohm and this P2 is 1.5 ohm. Now here you can see this negative is connected to the positive. So when this negative is connected to the positive, of course these two cells are connected in series. But right now we will not subtract their EMF. We subtract the EMF when the opposite poles are, when the same poles are connected, right? So here total EMF will be E net, total EMF will be E1 plus E2. Why E1 plus E2? Because opposite terminals are connected and they are in series. So it will be 1.5 plus 1.5. That would be 3 volt. Now we have to calculate the total resistance. So R net would be R1 plus R2 plus, let me say this is capital, plus capital. So R net is equals to 0.5 plus 0.25, 0.25 plus 2.25. So R net would be how much? If you solve this, it would be 3 ohm. So that would be 3 ohm. So now I would be what? E net upon R net would be equal to 3 upon 3. So I is equals to 1 ampere. So this will be the current flowing through this circuit, right? Now he is asking you one more question here. And he is asking you the potential difference across the terminals of the first cell. He is asking you the potential difference across the terminals of the first cell. So how much current is flowing? So the current which is flowing is I. And how much is this value of I? I is 1 ampere. So if the current is 1 ampere, now if the current I is 1 ampere and this R, which is the internal resistance, is 0.5 ampere. How much will be the voltage drop? Voltage drop will be small v is equals to I into R, which will give you 1 into 0.5. That is, voltage drop will be how much? 0. This much. It means when an EMF flows through this cell, a voltage drop because of the flow of current and because of the internal resistance. That is, this much voltage drop will come in the EMF. Right? So EMF is 1.5 volt. Voltage drop is this. So terminal, capital V we denote, terminal potential difference will be 1.5 minus voltage drop. EMF minus this. So it will be EMF minus voltage drop. So it will be 1.5 minus 0.5. So that would be 1 volt. I hope this is clear. Now similarly you have to do it for this. Okay. So again the current would be same 1 ampere and resistance is this. Calculate the voltage drop. V is equals to I into R. Subtract that voltage drop from the EMF and you will get the terminal voltage for the other cell as well. So this was the last topic of the first chapter of unit current electricity, and now we will start the second chapter. Thank you.